Alright, so with this video we're going to talk about how to find key points of a quadratic. We're going to look at how do we find those points using a graph, like what you see here, and how do you find those points using an equation. Now, using a graph should be the easy part, but first let's figure out what the key points are that we need to know for a quadratic. Hopefully you remember from Math 1 some of the key points that we like to find with quadratics and any of our graphs for that matter. We like to find the y-intercept, which is of course where the graph hits the y-axis. Alright, so we like to find the y-intercept, which in this particular graph, and hopefully you'll agree with me that this is a quadratic, it's a smiley, right? You'll notice that it hits the y-axis here at this point. And if we actually count up and find that value, here's 0, 0, and we go up 1, 2, 3. So the y-intercept for this particular graph is going to be at y equals 3. All right, so there's the first point that we want to find. So you always want to find the y-intercept. Now, going along with that, we also want to find our x-intercepts. So again, we're going to look along our x-axis this time. X-intercepts are where your graph or function intersect with the x-axis. So here is an x-intercept. Here's the other x-intercept. Remember, with your quadratics, you can have 2, 1, or 0 x-intercepts. So be careful with that. In this case, we have 2. Both x-intercepts are on the positive side of our x's. We've got one at 1 and the other one at 3. See, 1, 2, 3. So our x-intercepts are at 1 and 3. You'll notice I wrote that with an and sign. That's supposed to be an and sign, not a plus sign, and not commas. If I had put commas here, it would have looked like a point. So be real careful with that. Make sure you put 1 and 3. Now, with quadratics, we also like to have identify our minimum or our maximum point values. So looking at this quadratic here, it has a minimum value, which means it has a lowest point and then it starts to go back up. So the minimum value is located here at this point. Okay, so if we just count our points, we go over to the right, 1, 2, and down 1. So the point for our minimum is at point 2, -1. All right, so those are your key points, the key features of what we want to find with our quadratics. The other thing we also want to take note of, is this a smiley or a frowny quadratic? Okay, and in this case it is a smiley, so if you remember what that indicates with your equation is that your x squared is going to be positive, okay, and that makes it a smiley. So those are the key points when you're looking at a graph of a quadratic. Now let's look and see how we can find this using the equation. All right, so let's say we have the equation y equals x squared minus 4x plus 3. Now this is a quadratic equation. Remember, it is it has that x squared, so that makes it a quadratic. All right, so first thing we want to do is we want to identify the y-intercept. Now you can do a couple of different things when you're given the equation of a quadratic to find your y-intercept. First, you can just look at the equation. It tells you what the y-intercept is without you actually having to do any work. Your y-intercept is going to be this last value here in the equation that does not have a variable attached to it. So your y-intercept for this particular quadratic is at +3. Now, if for some reason you don't remember to look there, or you have a brain fart or something, remember your y-intercept is located on your y-axis, which is where x equals 0. So you can also substitute in 0 for x and solve it. So if we do that part, we're going to do 0 squared minus 4 times 0 plus 3. Well, 0 squared is 0. Negative 4 times 0 is 0. plus 3, 0 minus 0 is 0. Okay, and so you're left with 3. So algebraically, this is how you'd find your y-intercept. All right, so we've got that first point. I'm going to circle that there to remind us that we have that. Now the next thing we want to do is find our x-intercepts. When you're given the equation, you can do a couple of different things. You can factor, or you can use your quadratic formula. Okay, so whichever way you want to go, just go with it. Now in this case, this equation I know can be factored. Number one, because I wrote it that way, and number two, you can look at these values and see, oh look, it can be factored. All right, so we're going to factor this equation. All right, and remember, by factoring, you set up your two sets of parentheses. Go here to your first term. What times what gives you x squared? Hopefully you said x and x. Remember, those go in the first spots there in your parentheses. Then you look at your last term. What times what gives you positive 3? Now you also have to say, okay, well, what times what gives me positive 3, but then adds up to 4? And so hopefully you know that 1 times 3 gives you 3, and somehow 1 plus 3 gives you 4. Now you'll notice that the 4 is negative, so this actually needs to be a minus 1 and a minus 3. All right, so this is factored correctly. Now to actually find our x-intercepts, we have to take each parentheses and set it equal to 0. Solve for x. So our two x-intercepts are at 1 and 3. Okay. Now if you used your quadratic formula, remember your song. Your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so you can also use your quadratic formula. Your quadratic formula works every single time to find your x-intercepts. Factoring is for special cases. It doesn't work every time. You can get some pretty funky looking numbers there. All right, so next we want to find our minimum or our maximum. Since we know our equation has a positive x squared, we know this is a smiley. We know the graph is a smiley, quadratic, so that tells me that it's going to have a minimum value. All right, so we'll just set that off to the side. We know that. Now, in order to find that point algebraically, the first thing you need to do is find your axis of symmetry. So your axis of symmetry is actually the middle point of your quadratic. So if you drew a line right up the middle there and split it in half, that's your axis of symmetry. And if you remember, that's where your minimum and your maximum are actually located. So we want to find that axis of symmetry. To use that, you're going to use part of that quadratic formula. You're going to take the negative b over 2a part, and this right here is going to find you your axis of symmetry. So in our equation, we know that a equals 1 because that's the coefficient in front of the x squared. It's a 1. And we know that our b is going to be negative 4. So we substitute those values in. So again, we have negative b. So the negative of negative 4 is actually positive 4. And a is 1, so we substitute that in. 4 over 2 equals 2. So your axis of symmetry is located at x equals positive 2. Now, your minimum is located on your axis of symmetry. So, since we know that x equals 2, we can now find y. You take your 2, substitute it in for your x values, and find y. So y equals 2 squared, whoop, can't see that, minus 4 times 2 plus 3. Simplify. You get y equals negative 1. So your minimum point is at point 2, negative 1. And that's how you find your minimum. So we've gone through, found our y-intercept, our x-intercepts, and our minimum value.